Hello, this is Dr. Brandon, and in this slide presentation, we're going to be talking about the Turing test and the Chinese room argument. And this is really just to give you an overview of these things. So let's start with the Turing test. So the Turing test is a test meant to determine whether or not a computer has artificial intelligence. The computer passes the test by functioning as a human during a conversation. If the test giver cannot distinguish between the computer and a real human being during a conversation, then a test is passed. So the idea is that you would engage in a conversation with something that you didn't know if it was a human or a computer. It would be in the next room or something like that, and you would send messages to it, and it would respond. And after a set period of time, if you could tell that it was a computer, then the Turing test would be passed. And if it's passed, it means that whatever is in the other room has artificial intelligence or consciousness, really, right? Is some kind of a self-aware being that can engage in its own self-directed thinking, and that is self-aware and all of those things that go along with being a thinking being, right? So that's the idea of the Turing test. It's just a test of how something is functioning. If something can function as a conscious being, then we should think that it is a conscious being. That's the idea. Now, the Chinese room argument is really an argument used to criticize the effectiveness of the Turing test. The Chinese room argument supposedly shows that even if a computer passes the Turing test, this does not mean that the computer is a true artificial intelligence possessing consciousness and understanding. In other words, just because a computer functions in a way that cannot be distinguished from a human being does not mean the computer possesses artificial intelligence or consciousness. And so that happens in the Chinese room argument. If you remember from the reading, if you're in the room and you're able to produce the appropriate text or scripts in Chinese, someone outside of the room will think that you understand Chinese, but you really don't. And so the idea is that if a computer program can produce the correct words, then it seems to be understanding what's going on, but it's really just running a program it doesn't understand. So that's what the Chinese room argument is saying, that the Turing test itself is not an effective way to determine whether a system has artificial intelligence or has consciousness, right? That's really what it's a test about. And this brings us to the distinction between syntax and semantics. So syntax has to do with the order of words and symbols in a language. Semantics deals with the meaning of words and symbols of a language. So if you think about a computer program, it's a set of instructions for a syntactical manipulation. The computer program is going to take a string of symbols in a way, right, and manipulate them and produce another string of symbols. It's all syntax. It's not semantics. The computer doesn't need to understand English or Chinese to manipulate these symbols. And so the problem with the Turing test is that it looks like it's testing whether a system can manipulate the syntax correctly, but it can't really test if a system is truly understanding what's going on. And this leads us to the last thing about brains and minds. So if the Chinese room argument is correct, then there must be something more to consciousness than a machine running a program. There must be more to thinking than syntax. And John Searle, the philosopher who came up with the Chinese room argument, he kind of uses the Chinese room argument to say, well, it doesn't look like these machines are going to be able to think because all they're doing is running a program, syntactical manipulation. But then he's a materialist, so he goes and says that somehow brains are causing minds. And it's not really clear what he means by that. But if brains are causing minds, then it might be possible to make an artificial intelligence. You just have to make a machine that's like a brain. And if you can make an artificial brain, right, and brains cause minds, then it looks like you could create a machine that does have a mind. So it looks like that's a possibility. So even though the Chinese room argument might rule out a certain kind of artificial intelligence, and artificial intelligence just based on a program, right, just running a program on a machine, that might not be enough. But if you can make a machine that kind of functions or mimics a brain, then maybe that is a way to produce artificial intelligence.